Hello, my name is Jennifer Trueblood, and this is a pre-recorded presentation for the 2021 meeting of the Society for Mathematical Psychology. In this talk, I will be discussing work with Abigail Sussman at the University of Chicago Booth School of Business, examining the effect of wealth predictions on financial decisions. The key question that I will be investigating in this talk is how do people's beliefs about their future wealth impact the financial decisions they make today? The overarching hypothesis that we will be examining is that beliefs about future wealth serve as reference points when making financial decisions. This idea stems from work in behavioral economics suggesting that expectations determine reference points. For example, previous work has shown that participants' expectations about payment influenced how long they were willing to work. And another study found that professional golfers' performance is influenced by par. In this talk, I will discuss 3 studies. The first study was conducted on Amazon Mechanical Turk with 196 participants. Participants completed 2 tasks in this experiment. One task involved making predictions about the future values of assets and debts for 20 different financial profiles in 1 year. The second task was a choice task between an interest-based savings account and a prize-linked savings account for all 20 profiles. There were 2 between subjects conditions, and one condition participants only saw positive net worth profiles, and in the other condition, participants only saw negative net worth profiles. We randomized the order of prediction and choice task, and there was a distractor task between the 2 tasks. This is an example of a prediction question. Participants would see something like the following. Imagine you have $214,000 in assets and $148,000 in debt. They would then answer 2 questions. First, they would be asked to estimate what your assets will be in 1 year from now, and they typed their response into a text box. Then they would be asked to estimate what your debt will be in 1 year from now, and they also typed their answer into a text box. This is an example of a question in the choice task using the same financial profile as the previous slide. Participants saw something such as, imagine that you have $214,000 in assets and $148,000 in debt. You plan to invest half of your assets. Which bank account do you prefer? They then had a choice between 2 savings accounts. In one account, they had a 0.8% chance of winning $267,500 in 1 year with no interest. In the other account, they could earn 2% annual interest, which would earn them $2,140 in 1 year. On the previous slide, the first choice that people had, savings account A, was what we call a prized-linked savings account, or PLS account. This type of account does not offer interest, but instead incorporates a lottery-like drawing with a low probability of a large potential upside. Over the past many years, there's been growing interest in the use of PLS accounts to increase household savings rates, both in the United States and around the world. Currently, about half of the states in the US have legalized PLS accounts. I'm going to first show you the prediction results. Overall, participants thought that assets would grow, and this is true for participants in both the positive and negative net worth conditions. Overall, participants thought debts would shrink. Again, this is true for both positive and negative net worth conditions. So in general, participants were optimistic about the future. Here are the results for the investment decision task, showing the different asset amounts for the profiles on the x-axis and choice for the prize-linked account on the y. The 2 different net worth conditions are shown in the 2 colors. And as we can see, there's not really much of a difference between those 2 net worth conditions. Rather, what we see is that choice for the prize-linked account seems to be associated with the value of the asset amount. So profiles with smaller assets generally tended to be ones where there were more choices for the prize-linked account. We're going to try to understand this data by modeling it using prospect theory. And in particular, we're going to examine a couple of different variants of prospect theory models. And we're going to develop these variants by making some modifications to the value function. So in our models, we will be modeling the value for each of the different savings accounts for each of the profiles. And we're going to be comparing the amount offered by the savings account for a particular profile to a reference point for that profile. So these reference points are profile dependent, so there will be up to 20 of these for the 20 different profiles. We will allow for up to 2 free parameters in the model. Alpha here is the risk aversion parameter, and we will also allow in some of our models a loss aversion parameter, lambda. We will compare 4 versions of prospect theory. The first version is a 0 reference point model. This is a 2-parameter model. It has a risk aversion alpha parameter in the value function. We modeled choices using a logit choice rule, which contained a choice consistency parameter. The second model is a reference dependent model. This is a 3-parameter model. Here, reference points are growth rates from the prediction task, and I'll explain what that means on the next slide. The 3 parameters are risk aversion, loss aversion, our lambda parameter. Note that in the reference dependent model, we can actually end up with losses in when we calculate the value function, and so lambda has to be included. This is not the case for the 0 reference point model. All the values are positive numbers. And then finally, we have a choice consistency parameter in the logit. We wanted to compare the growth rate reference point model with alternative models that included a non-0 reference point. And so we considered 2 such models. The first is a negative reference point model where the reference points are growth rates from the prediction task but multiplied by -1. So here we have risk aversion and choice consistency in the logit. All the values are positive in this case, so there is no loss aversion. And then our fourth model is a random reference dependent model. Here the reference points are growth rates from the prediction task but shuffled so that the profiles in the prediction and choice task were mismatched. And this is a 3-parameter model with risk aversion, loss aversion, and choice consistency. So in our models with reference points, we used participants' growth rates. And this was calculated just as a simple growth rate where the future value was generated by the participant. So that is their prediction that they give in the prediction task. And then the present value is the amount stated in the question. So we calculated a reference point for each of the 20 profiles, and we did that by calculating the growth rate for assets in profile I from the prediction data as described on the previous slide, and multiplying that by the assets for that profile divided by 2. We divide the asset amount by 2 because in the choice task, participants are told they can invest half of their assets. Here are the modeling results. On the left, we have 3 of the 4 models illustrated. These models were fit using hierarchical Bayesian methods. The model is in purple, and then the data is in blue and in orange. The 0 reference point is on the top, the growth rate reference point is in the middle, and then the negative growth rate reference point is on the bottom. We compared the models using the deviance information criterion as shown in the table on the right. And we can see that the growth rate reference point model had the lowest DIC and was thus preferred to the other 3 models. So just some quick conclusions from study 1. So beliefs are generally optimistic. People believe assets will grow, debts will shrink. Choices in the investment decision task varied by the asset amount, but not net worth. In particular, people were more risk-seeking, that is, they preferred the PLS account when assets were small. And finally, choices were best accounted for when beliefs were included as reference points in prospect theory. Our second study is a replication of study 1. This is a replication with a new set of profiles where net worth varied and assets were fixed. I'm not going to go into all of the details of this study, but I will mention that the prediction and choice results replicated study 1. That is, choices varied by asset amount, but not net worth. And choices were best accounted for when beliefs are incorporated as reference points in prospect theory. So we compared the 4 models that I mentioned for study 1 with this data, and the results were identical. So an important question is, what does the growth rate reference point model imply about how people think about gains and losses in financial decisions? And so to answer this question, we performed a model simulation for the 80 different profiles used across both experiments 1 and 2. And we did this by varying the growth rate reference point from 0 to 0.3. And the results are shown here in the top. And what we did for this plot is we averaged over the 80 different profiles for the different values of risk aversion. So we varied the risk aversion value from 0.1 to 0.9, as shown here. So what we can see is when the growth rate is small, that is what is between 0 and 2%, choice proportion for the prize-linked account drops off sharply. And so in both experiments, the traditional savings account offered a 2% annual interest. And when your belief about how your assets will grow is less than 2%, then that traditional savings account appears as a gain. However, when the growth rate is greater than 2%, that 2% interest offered by the traditional savings account suddenly appears as a loss. And so you have a decision between a sure loss offered by the traditional savings account and a mixed gamble, which is the prize-linked savings account. And we can see in this case, choices for the prize-linked account increase quite a bit, and the amount that they increase is dependent on the alpha or risk aversion parameter. In the bottom panel, I'm showing the data from experiments 1 and 2, all 80 profiles combined, plotting the asset growth rate on the X and choice for the prize linked on the Y. And we can see that the general pattern here is in line with what we see with the model predictions. So overall, what we're learning from this model is that if someone's belief in their the growth of their assets is greater than what is being offered in interest from a financial product, then that can actually make that product psychologically appear as a loss, even though it's objectively stated as a gain. Our final study that I'm going to tell you about is a survey of beliefs in stock market decisions. This survey used a nationally representative sample of 4,606 participants. Participants in this survey answered a lot of questions, but I'm going to focus on 2 of them. The first asked people to think about their assets and debts at the beginning of January 2020, prior to the COVID-19 outbreak in the US. Relative to that, what do you predict that your assets and debts will be in January 2021? And another question participants were asked, imagine that you received $1,000 that you did not need to use right away. How much of this money would you invest in the US stock market versus a bond earning 2% with certainty? Here are the results from the study. What we're showing is the proportion of $1,000 invested in the stock market index for individuals grouped based on their predicted change in assets. So we see that people who believe their assets will grow more than 2% invest a larger proportion of the $1,000 in the stock market as compared to participants who have lower asset growth rates. These results hold when we control for beliefs in the stock market itself. These are questions asking people to predict the future value of the stock market in 1 year and 10 years. And so that means that these results are reflective of people's beliefs in their own personal assets and not just beliefs in the trend of the stock market. So to conclude, people have a positive outlook on their future financial state, and beliefs about future asset levels alter decisions by acting as reference points. So in studies 1 and 2, optimism about future wealth increased risk-taking by making the small amount of interest in the traditional savings account appear as a loss. And results were corroborated in a large-scale survey examining investment decisions about the US stock market. I want to thank you for paying attention. If you're interested in learning more about this work, you can find a preprint on the Psych archive.